continue talking about parentheses.
It's called valid parentheses.
Yeah.
This will be a last day of parentheses.
Yeah, well done. So remember, previously we talked about valid parentheses only including these brackets, right? Yeah?
Yeah.
How about if we also
Curly brace.
consider curly brace and square bracket? Yeah? So if it's a valid parentheses, it could be something like that. Yeah? Something like that. Do you get it? Yeah, this is a valid because everything is in pair. But this is not in pair. This is not. This is not. Do you get it?
Yeah.
This is not. Right? Because even it's open and closed, but this does not match. Right? Yeah? Okay, so our task is to design an algorithm. Yeah? Algorithm to solve this problem. Okay?
Yeah.
Right. Yeah. Thank you for doing that. So, remember, any ideas? I mean, how do we do that?
I don't understand what we're doing.
I was just talking about that. I mean, to check if it is a string like that, if it's a value, this should give me false. This should give me true. Yeah. This true. This true. This false. Okay. So remember previously we use a balance counter, right? When we meet the opening, we +1. When we meet the closing, we -1, and we check if it's 0, right? If any time it falls below 0, then it's invalid, am I right? Because if it falls below 0, it means we don't have enough opening brackets. Like this. 1, 0, -1. When it's negative, when it's below 0, it means we don't have enough opening, am I right? So it means we return false immediately.
So if this add 1 and this one -1 and this add 2 and this -2 and this add 3 and this -3.
No, look,
No.
it could work a little bit, but no. Look, if you add 2, what happens? Like if you're saying that this add 1 and this add 2, right? And this add 3, right?
Yeah.
How? Okay, so if this add 2 and this is -2, right?
Yeah.
And how about this? 1, 1, 2, 1, 1, 0. This is apparently not valid. Yeah? You get it? So this approach does not work. Got it?
Yeah.
Okay. So the tricky part is that we need to check if the opening is the one we want. Okay? If it, yeah. So remember we talked about the stack before. What's stack? Can you remind me?
First in, last out. No, first in, first out. First in, first out. Last out.
Last out. First in,
Yeah.
last out. First in, first out is Q.
Q. Q. FIFO.
You are right there at the beginning, yeah? Why you change your answer to first in, first out?
Yeah.
Okay, so the stack visually, okay? If you put something in, if we put Eric in, yeah?
Got it.
Then we put Ryan in.
Which is this guy
And
over here.
Then we put the mommy in, okay?
Then daddy.
Then daddy in, okay? And then
Then
when
grandpa.
That's
Right
it.
here, but.
okay, so when we pop an element from the stack, daddy go out first, yeah? And then mommy, yeah? And
And then-
Ryan and Eric. You see, Eric goes in first, but last out, yeah? Yeah, okay. So that's first in, last out. So how about if we meet these
And then
or
that
these?
one's set.
If we meet one of these, yeah?
Yeah.
We put it.
FIFO.
We put it here. Put it in
Oh,
the
FIFO
stack.
and FIFO.
For example, like this. Let's example, okay? Okay. Yeah. This is a value. If we put,
I said,
yeah.
if you need whatever you start, you have to find me out of it.
Yeah. Look. Going this way. Yeah. Opening. I put it here. Yeah.
Yeah.
Another opening. I put it here. Another opening. I put it here. Okay. Now it's closing. Yeah. When we meet any of these, we look at the top of the stack, right? Okay, this top of stack is this. Does it match this one?
Yeah.
Yes, then we continue. We take it out, we continue. Does it match this one?
No.
Yes, we take it out. Yeah? Does it match this one?
No.
Yes. We'll take it out. Yes, yes. And then look, if it doesn't match, then for example, if it doesn't match, like that, okay? Yeah? Doesn't match. This is the set. Yeah?
Yeah.
If it is does not match, right? Then we return false immediately. You see? And at the end, we need to check if the stack is empty. If it's not empty, it means that some brackets are not closing, right? Like this. If you look, I push twice curly brace, brackets, and then I mean this one. I take this out. It match, yeah? Okay. And look what happened. We have one more. Needs to be closed. So it's not a valid one. Does it make sense?
Yeah.
So this stack is very useful in this case, yeah? Okay, let's write the problem. Can I have eraser, please? Eraser man. Eraser man. Okay. Okay, that's it. Okay, look.
No.
Define.
Fine. Of course.
Okay, this is running out of ink.
Then why do
Define
you choose it?
valid parentheses. Yeah.
Then it says S.
S and
Column. Yeah.
this is bad.
ST equals
Wait.
equals left
Look.
brackets. Yeah.
So ST equals
Equals,
ST stands for stack.
yeah.
And then this empty bracket, this means the list, but we can use it as a stack, right? Remember?
Yeah.
Okay. So when
Why you know? Yeah.
for I is
Column.
S column.
Yeah.
That's okay. So now we need to find out if I in, look, we can use in to check if this is in this list, right? So
Another column.
if it's in the open bracket, curly brace,
And then
square bracket, if it's one of these, yeah? If it's one of these, then we push it into the stack. Stop the append, right? We
Yeah.
push it into the stack.
I.
Else, right?
I
if I in
all of the closing brackets.
yeah, closing bracket.
If the left.
Wait. Closing bracket. Then we need to check. When we mean this, we need to check.
If left.
Ryan, then we need to check if the stack is empty or not, right? If we already mean this one, if at the beginning the stack is empty, right? If we have the closing one, it's invalid. We can't pop any element. There's nothing in the stack, right?
Yeah.
So we need to check in this case. If there's nothing in the stack, it's invalid, right? So we need to check if ST is 0.
Equals 0.
That means
Or
the stack is
not
there.
stack minus 1.
Wait. Look. Yes, you are right. ST minus 1 means that the top of the stack, right? Look, if we are using a list, like if the list is 1, 2, 3. Do you still remember this? If a list is 1, 2, 3,
Yeah.
then minus 1
Yeah.
is 3, yeah? The last element.
Yeah.
0 is the beginning, right? Can
Yeah.
I have the eraser, please?
Yeah.
Okay. That's it. Okay. Then or
Woo!
if the previous stack, the top of the stack, right? If the top of the stack is this one. If the top of the stack plus now current one is also in what? In this is a valid pair, yeah? This is a valid pair. This is a valid pair, right? If not in, this is a valid pair, but we are looking for not. So not this one, column, return false, right?
Yeah.
And then after that, we need to pop this from the stack.
ST dot pop.
This is pop the last element. If we want to pop the first element,
Return left. Left. Left.
And
Left.
t equal 0.
Yeah.
we need to check if it's this is empty, right? The stack is empty. Okay, so can you tell me if I want to check the beginning of we want to if the list is 1, 2, 3. If I want to pop this element out, first in first out. How do we do this?
First in, first
So
out.
3, he needs to go out, so he goes out.
Yeah, that's st.pop, right?
Yeah.
And how about if I want to pop the 1 out? What do I do?
Need to go the 2
Two
down.
down. 2 then 1.
No. What I'm saying that if we are using this stack, this as a queue, we want to pop the first element out,
Yeah.
and we need to pop 0. Remember, this 0 means the first one. Yeah. Yeah. Pop
Yeah.
0. Okay. Okay. So this is the basic. So what's the complexity?
What's the complexity?
Oh,
N.
because
Yes.
n is the number of the character in the string.
Uh,
How about the space complexity? Yeah, space complexity. Do we need to allocate a space for this problem?
no.
Why not? We are using a stack. Why not?
Because.
Because
What's your
I
opinion,
need the
Eric?
toilet.
So you go.
I don't actually need it.
Sorry?
I don't know.
You say it bravely. It doesn't matter.
I don't know.
Make a guess.
I don't know.
It's on the board. What's the space complexity?
O-N.
Yeah, well done. Because we're using a stack. Yeah?
Yeah.
We're using the stack. In the worst case, the stack, for example, if the string is always opening, yeah? It doesn't matter, it's always opening. There's no popping, right? Alright? Then the stack will contain these all elements, all opening brackets. So it needs, when there are n characters in a string, you need another space which contains n elements in the stack. Am I right?
Yeah.
Yeah, that's why it's called ON complexity in both time and space.
I thought it was N because you just need to scan it once. Easy.
No. Scanning once. That's because of time.
No.
Yeah. When we talk about time, we talk about how many iterations the computer needs to process, right? But this stack is we are using an additional storage to keep the elements, right? And in the worst case, there's no popping from the stack. In the worst case, the string contains all the push, right? All the opening, and then this stack needs for example, if like 100, a string size is 100 characters, and then need a stack which can hold at least 100 characters. Do you get it? Yeah?
Yeah.
This is what it means by stack. Okay, good job today. The last thing.
Say goodbye. Bye. Bye.